Let's do an example of a more complicated rational equation. Let's solve the rational equation x plus 1 over x minus 1 equals negative x over x plus 3 plus 8 over x squared plus 2x minus 3. Now the first thing that I'm going to do is I'm going to factor all the denominators in this problem. This is going to help me in two ways. First, it's going to allow me to see all of the bad x's, all of the x's which we would not be able to plug into this equation. And two, it's going to help me to find the LCD of these fractions so that I can use that to multiply both sides of this equation. Now, the only fraction in this problem that is not already completely factored is this denominator here on the right-hand side, x squared plus 2x minus 3. So let me go ahead and factor this as x plus 3, x minus 1. And we can check plus 3 times minus 1 returns minus 3, plus 3 plus negative 1 returns positive 2. Our last denominator contains copies of the first two denominators. So our LCD will just be equal to that x plus 3, x minus 1. And the bad x's, the x's that we would not be allowed to have for solutions, would be the two values of x which make this value 0. So x equals 1 would be bad, and x equals negative 3 would be bad. Alright, now that I've done that note keeping, let's go ahead and take our LCD and multiply a copy of it to every single numerator in this problem. Alright, so we have one copy of the LCD for fraction number 1, another copy for fraction number 2, another copy for fraction number 3. Now fraction number 1 was equal to x plus 1 over x minus 1. Fraction number 2 was equal to negative 8 over x plus 3. And fraction number 3 was equal to positive 8 over x plus 3, x minus 1. So let's see what we can clean up here. If I look at these fractions, I have a x minus 1 in the numerator on the left, and an x minus 1 in the denominator here. So those two cancel each other out. Moving to the second fraction, we have a common factor of x plus 3 in the numerator and x plus 3 in the denominator. And then looking at the last fraction, we have an x minus 3, x minus 1, which both cancel with the x plus 3, x minus 1 in the denominator. So, being able to eliminate all of that, let's see what we have left. We now have x plus 3 times x plus 1 equals x minus 1 times negative 8 plus positive 8. That is what survives after simplification. So now that we've cleared the fractions, let's go through and let's try and solve this for x. The first thing that I'm going to do is I'm going to do all the distribution in this problem. So if we distribute the first product, we get an x squared. We get 1 times x from the outer product, so I'll write that as just x. We have 3 times x from the inner product, and we have plus 3 from the last product. On the right side of the equal sign, we have negative 8 times x, and we have negative 8 times negative 1. Okay, now let's clean up just by combining a couple of like terms. For example, I don't need plus x and plus 3x. I can turn this into plus 4x. I don't need plus 8 and plus 8. I can turn this into plus 16. Alright, so now the equation that we have is quadratic. As indicated by the presence of the x squared in this equation. And quadratic equations are usually solved by moving everything to one side of the equation so that we can get a 0 on the other side of an equation. So let me move over the 8x, and let me move over the 16, and we get x squared plus 12x minus 13 equals 0. Now that we have 0 on one side of the equation, we have two options for solving this quadratic. We could either use quadratic formula, or we can see if this can be factored. And I think this can be factored, so that's what I'm going to do. Let's solve by factoring. Let's use the zero product property. This splits as x plus 13, x minus 1 equals 0. And let's confirm, positive 13 minus 1, the product of that is negative 13, and the sum of those two numbers is positive 12. So that leads me to the two solutions, x equals negative 13 and x equals positive 1. Now I have a question for you. Is this my final answer? We have to be careful because whenever we're solving rational equations, there's a possibility that one of the x's that we obtain is a fake solution. In particular, I'm looking at this x equals 1 that we obtained. Let's compare that against the bad x's that we established at the beginning of the problem. We found that x equals 1 was a bad x, and it was not in the domain of our fractions because it makes this first denominator 0. So let's go ahead and let's discard x equals 1. Discard makes a denominator 0. But x equals negative 13 is a perfectly acceptable solution and is not equal to either one of the bad x's that we established at the start of the problem. X equals negative 13 does not make any denominator 0. So here's our final answer. For the final answer, I would give the one valid solution to this problem, x equals negative 13.